So in this question, we're told that there are some counters in a bag and that the counters are red, white, blue or yellow. We're told that Bob is going to take a random counter from the bag, and we're given a table which shows each of the probabilities that the counter will be blue or yellow. So we have in the first row the colour, so red, white, blue or yellow, and the second row the probability of the counter being that colour. Red and white aren't filled in yet. Blue is 0.45 and yellow is 0.25. We're told that there are 18 blue counters in the bag and that the probability that the counter Bob takes will be red is twice the probability that the counter will be white. And we're asked to use all of this information to work out the number of red counters in the bag. So initially here, if we want to find the number of red counters, we need to find the probability that the counter is going to be red in order to work with this and the total number of counters, which we can also calculate. So if I have a look at the information that we have, we're told that the probability the counter is red is twice the probability that the counter is white. So we could kind of fill this in. If the probability of a counter being white is x, the probability of it being red is 2x. Now, the counter that's picked has to be either red, white, blue or yellow, so all of their probabilities need to sum to 1 because they're the total, they're all of the things that can happen. Nothing else can happen if a counter's picked. So therefore, we know that 2x plus x plus 0.45 plus 0.25 is equal to 1. And if we add these x's together, we get 3x is equal to 1 minus 0.45 minus 0.25. And that gives us an answer of 0.3. So we now know that x is 0.3 divided by 3, so 0.1. And the probability of the counter being red is 2x, so 2x is equal to the probability of the counter being red is equal to 2 times 0.1, so 0.2. So we now have the probability that the counter is red. If there are 18 blue counters in the bag, we also have the probability that the counter is blue. So the probability that the counter is blue is 0.45, and that is equal to 18. So there are 18 blue counters. Now we can work out the total number of counters if we kind of take this as a fraction. So 0.45 lots of the total is equal to 18 counters. So if we let little t be the total number of counters in the bag, 0.45 multiplied by this gives us 18 counters, so those are 18 blue counters. So if we divide both sides by 0.45, we can take 18 divided by 0.45 to get us the total number of counters being equal to 40. And now if the probability of choosing a red counter is 0.2, we can simply multiply this by the total. So 0.2 multiplied by 40, as there's a 0.2, there's a probability of 0.2 of picking a red counter, and there are 40 counters to choose from. And 0.2 multiplied by 40 here gives us an answer of 8. So there are 8 red counters in the bag. Now, as for how each of the marks are awarded in this question, we would gain a first mark for finding the sum, for a process to find the sum of the unknown probabilities. So for finding the 0.3 here. The second mark is for finding the probability of the red counter or a white counter being chosen. So this 0.2 here we calculated. The third mark is for a complete sort of process calculation to find the number of red counters. So there's a multiplication by either finding the total or something similar here. And then the correct final answer of 8 gains us the fourth and final mark for this question. So now for the second part of the question here, we're told that a marble is going to be taken at random from a box of marbles. The probability that the marble will be silver is 0.5. And we're told that there must be an even number of marbles in the box and asked to explain why this must be the case. So the probability that this marble is silver is 0.5 or a half. So that basically means that half of the marbles are going to be silver marbles and half are not silver. And if half of the marbles are silver, half of the number of the total marbles needs to be a whole number, as we can't have half a marble. So this is where the even or odd comes into play. So if we're to half an odd number, it's never going to give us a whole number. So for half a number to be an integer, that number, the original number, must be even, and you can't have half a marble. So this means that there must be an even number of marbles in the box in order for this to work and for there to be able to be a probability of a half. So to get the mark here, I'm just simply going to write a half multiplied by an odd number will never be a whole number. And also, it's a good idea to add here, you cannot have half a marble. So you need a whole number of marbles in the box. You can't have half a marble, so you can't choose half of an odd set of numbers, as this will not give you a whole number, so this is not possible.